see the definition here, you say, okay, well, if f of minus x equals f of x, then it's even. But what you really need are some examples here. Okay, so the most basic one is this: is x squared even? Okay, and in this case, f of x is x squared. That's our starting point. And what you do is you replace, you kind of come off to the side and you say, okay, well, what is f of minus x? And what that means is wherever you see an x in the original, you replace it with minus x. And I mentioned this last time, when you substitute in, it's good to use parentheses. Okay, so what does this reduce to? Do you know, when you have parentheses minus x squared, what happens to the negative and what happens to the x?
Oh, it becomes a positive.
It becomes positive x squared. We don't write the positive. And you ask yourself this question, you say, is this the same as the original?
Okay.
Is it the same as the original?
Yeah.
Yes. And if your answer is yes, the answer of yes means that it's even. Yes means that it's even.
Okay.
Okay, so let's do some other ones here that maybe aren't as obvious here. So let's say in the next example here, I say f of x equals x to the fourth minus x squared minus 2.
Okay.
And I ask the same question. I say, is this even? Well, here's your response. Your response is, well, let me try f of negative x. Let me put wherever I see an x, let me put a negative x. So negative x to the fourth minus x squared minus 2. And again, I'm going to keep saying this because it's really important. Whenever you substitute in for a negative, put it in parentheses. Like hopefully you see that above this is x to the fourth minus x squared minus 2.
Yeah, I can see that.
Okay, now order of operations. Order of operations tells you do the exponent before you do the other stuff. And so, like you don't deal with this negative until you deal with the exponent. So here, what is negative to the fourth power?
It's 4, isn't it? Or no, it's positive.
It's positive, yeah. It's like saying negative times a negative times a negative times a negative. Okay, so it's positive x to the fourth minus, and I'm bringing that one down. I'm not distributing it in. You can't do that. You have to deal with the exponent first. So you just did this for me. The negative becomes positive. Okay. So now you ask yourself, is this the original? Is this the same as the original?
Right, and it is.
It is. So it is even.
Okay. Okay, I get that.
Okay, so now that you understand this part, I'm going to build you a little flow chart here. So you're going to be given a function. Okay, and that's where you're going to start. Okay, and then the first thing you're going to do is you're going to figure out, well, what is f of minus x?
Okay.
We did that. We did that in these two problems. Do you agree with me? Like we did that. We did that here, and then we did that here. Okay. And then you ask yourself, you say, okay, you get an answer and you say, is it the same?
Okay.
And if that's a yes, that means it's even. Okay. But if it's a no, well, that's where we're going to leave off right here, because we're going to do something different. But no doesn't mean that it's odd. It just means that it's a no.
Right.
All right.
I think you also went over that it could be an either.
Yes. So before we do that, though, let's look at this problem that you were given here, number 6, and see if we can answer it. You actually know enough to be able to answer this now on your own. So is this an odd function? So just ignore that part for a moment, and just if you've got paper there, and again, I'll send you this as a PDF at the end. Hopefully you got that from last time. I want you to evaluate f of minus x. So take about 30 seconds or a minute there and see if you can figure out f of minus x. And I'm going to work it out here, but just give it a try, please.
Okay. So that would be even.
Yeah, so we're gonna throw in negative x. I'm gonna do it in parentheses, and
Mhm.
then you square before you multiply. So this becomes minus 4x squared. And you ask yourself, is this the same as the original?
Right.
Yes.
Mhm.
Okay, so if the question were like determine whether the function is odd or even or neither, you would say it is even, right?
Right.
Okay, now we're going to come back to this, but like like this is kind of the best example here of how to do this. So now let's talk about what it means for a function to be odd. So if it's odd, f of minus x equals minus f of x. So let's look at an example of this where it's true. Let's say f of x equals x cubed. And just like before, you have to find f of minus x. So f of minus x is minus x cubed. What does this reduce to? Now, this time you have a negative to the power of 3. So that's like -1 times -1 times -1. What does that become?
That still becomes a positive.
But so the first two become positive, but then you got a third negative.
Oh, and that makes it negative.
That's right. So kind of off to the side here, we got another off to the side here. If you have a negative, let me do it differently. If you have a negative to an even power, this is always positive. And if you have a negative to an odd power, it's always negative.
Okay.
Do you follow that from this problem? See how it's 3 is odd, so it must be negative.
Yeah.
Okay, so this is negative x cubed.
Okay.
Okay, is that clear why that is?
Yeah.
Okay, so that's step 1. Step 2 is to factor out a negative. And you might think, well, okay, Matthew, that's right there. Well, you still have to do it. You say, okay, it's -1, or in this case, just the negative. Negative on the outside, and then on the inside is an x cubed. So I literally just rewrote this, but you have to do this step where you factor out a negative, and you'll see why in the next example. Is this part the original?
Yes.
And if that's the case, then it's odd. The answer is yes to this question, then it's odd. After you factor out the negatives. You first have to do the same thing we did in the even problems, but now you factor out a negative and you ask, is this inside part the original? And if it's a yes, then it's odd.
Okay.
Okay, so let's do another example here and make more sense here. So this next example is, let's say I gave you f of x equals 3x cubed minus x. Yeah, like that. And I ask you, okay, so I'm going to ask you to first figure out what is f of negative x.
Okay.
So if it's not clear, you're substituting a negative x for x wherever you see an x. And again, I'm doing it in parentheses, and I really recommend you do that. It really will help in the end, in the long term, if you can remember to do that. Just makes it easier with signs, things like that.
So with the negative x to third, I'm saying that wrong. The number 3, that would still be negative x, right?
It's negative x cubed, because the negative to the third power makes a negative. X to the third power makes the 3. But these are multiplying. Like this is really -1 here. Maybe that's not clear, but now it is. There's a -1 there, and you're multiplying. Is that not clear?
Yeah, that's clear.
Okay, let's just pretend like it's not here clear, because let me show you literally what it is here. Negative x to the power of 3 means the following: negative x times negative x times negative x. and there's a negative in front of each of those. And you don't want to do this every time, but sometimes it's good to see the expanded form so that you're like, oh, okay, now I get it. That negative times that negative times that negative makes negative. And then that x with that middle x with that last x makes x cubed.
Okay.
Okay. So, and then you're multiplying by 3. Okay, so you're multiplying by 3. We'll do that in the next step here. This one on the right is negative of a negative.
Right.
So that's plus x.
There's plus that.
Okay. Now we're going to distribute this 3 in. So that's negative 3 x cubed plus x.
Okay.
Okay. Now I'm telling you this is odd. Okay. Maybe I didn't say in the beginning, but this is an odd function. But you would know that it's not even, because if I said, hey, is this the original, Emma? Does this look like the original? You would say, no, it's not the same. It's got to be exactly the same. So that's step 1. What is step 2? It's to factor out a negative.
Okay.
So what does that look like here? Well, if you put a negative out, you're pulling a negative out of both of these terms. So it's 3x cubed minus x. So the negative becomes positive, the positive becomes negative.
Okay.
Is it clear or not?
No, it's not. I don't
Okay.
know.
Okay, that's okay. We're going to come back to that in a moment. Is this the original?
Yes.
It is. So since these are the same, we can say that it's odd.
Okay.
Okay. So let's talk about factoring out a negative. Okay. That you understand it. So we're talking about how to factor out a -1. So before we do that, we're going to put a negative on the outside. Let's say it's negative 5x squared minus 3x plus 2. Okay, we're going to distribute the negative to each term. So what that means is this negative goes to this number, it goes to this sign, and it goes to this sign right here.
Okay.
Is 5 positive or negative in here?
It's a positive.
It's positive. We don't write it, but it's positive. So now it becomes negative.
Okay.
This is subtraction. The negative turns subtraction into addition.
Right.
And this addition becomes
Subtraction.
So if you were to factor out a -1, it's like going in reverse. Okay, so when you put a negative on the outside here, this negative in front of the 5 has to change, this plus has to change, and this minus has to change.
Right.
So instead of it being negative, it's x squared minus 3x plus 2. So like when you factor it out, these change sign.
It goes to the opposite of what it was.
Exactly. Okay. Okay, let's try another one here. Is f of x equals 1 over, well, actually we can do this. Let's do x cubed minus x to the 5th. Is this even or odd? Okay, so to do this, it doesn't matter whether it's asked for even or odd. You have to first figure out, well, what is f of minus x?
Right.
So if you got your paper there, it's minus x cubed minus a minus x to the 5th.
Right.
Okay, so I need your help here. What is the negative to the power of 3?
That is negative x cubed.
Perfect. Okay. Now I'm going to leave this minus as a subtraction operator. What is a negative to the power of 5, x to the power of 5?
A negative also?
Yes. because a negative to an odd power is always negative, and then
Oh,
x
right,
to the,
yes. Okay.
okay, and then x to the, what's the exponent here?
The fifth.
Perfect. Okay, now you can distribute in this negative. So this becomes negative x cubed plus x to the fifth.
Okay.
So this is a step, you'll definitely want to review on your own, look at the notes again, so that it's clear. But now that we have this, this last line here, the first question I ask is this the same as the original? Is this the same as this line? It has to be exactly the same.
No.
No, so it's not even. To figure out whether it's odd, we have to factor out a negative. And when we did that in the previous example, you notice that each of these change sign. So if it's negative x cubed, what is it going to become in here?
It's gonna be a positive x cubed.
Positive x cubed.
And
This is
it'll-
plus x to the fifth.
It'll be minus x to the fifth.
Perfect. Now is what's inside the parentheses. What's inside the parentheses? Is this the original?
Yes.
Yes. So this one is odd.
Okay. That makes sense.
So it's a recipe. It's like do this, do this, do this, and ask questions along the way to get your answer. Now let me go back to your assignment here because we got to actually get some of these done, I'm sure. Give me get back to that. There it is. Okay. Let me have you do one more here. That's okay.
Okay.
Is that okay? We are going to get through your assignment, but
That's fine.
just this is purely for learning, of course. So let's say I tell you it's 2x squared minus 3x plus 2. Okay.
Yeah.
And you're gonna find f of minus x. Like that doesn't matter whether it's asking for odd or even, whatever it's asking for, even neither. You have to do this step. So it's 2 parentheses negative x squared minus 3 parentheses negative x plus 2. So take a moment here and see if you can simplify that on your own. If you can't, that's okay. I'll work it out with you, but go ahead and give that a try, please.
Okay. So I got 2x squared because it was a negative squared and it was an even number. It's a positive minus 3x and
Okay.
that became a positive, I believe.
So say they're both negative here.
Yeah.
So that's going to become plus 3x.
Okay.
All right. So definitely, if we got some time at the end, we're going to do a little more with that. But when you look at this line right here,
Yeah.
is this exactly the same?
No.
No. And the answer is no. So that means here's what that means. It's not even.
Right.
It doesn't mean it's odd. It just means it's not even. So then the next thing to do here, step 2, is to factor out a negative.
Okay.
So put negative on the outside. Okay. And you have to change the sign of each of these terms. If there's one term, you change the sign of one term. If there's 7 terms, you change the sign of every term.
Got it. Negative 2x squared minus 3x minus 2. And then it would be minus 2x squared minus 3x minus 2.
Okay, so then you ask the same question again. You look at what's inside parentheses and say, is this exactly the same as the original? And you got to go back to the original, not this other work, this first line or whatever you're given. Is that exactly the same?
No.
No. So this means it is not odd. So when you get a no and a no, that means it is neither or neither.
Okay. That makes sense.
Okay. All right. So I'd like to move to some of the questions on your homework assignment here. But you tell me, do you want any more practice on this? We can do some at the end, but we'll make sure we get through everything.
Okay. Yeah, it makes more sense now.
Okay. All right. So I think even functions are the easiest to visualize or to see. So we're gonna look at number two first. I guess I do need to snip in the entire answer space. These questions are given are qualitative questions. They're not very easy to do unless you have a mastery of the concept. So I'll try and help you work through this together. Even is really important here. Okay, you want to identify that word here. So even means the following. If I give you a graph, this line right here, this line x equals 0, or the y-axis, it's considered the mirror. Okay, so you have a mirror somewhere in your home, I'm sure.
Yeah.
Whatever you see on the right side has to match whatever you see on the left side.
Right.
That wasn't very good, but you get the idea there.
Yeah.
And that's what's so important about these even functions. The left has to match what's on the right, always, 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 always. So this has some information that is not important here, but let's there's some extra information. But what is important is it's saying, hey, if 6, 0, and I'll just say that that's 6, 0.
Yeah.
Okay. How far away from this is, or where is the mirror? See how this is the mirror right here, this line again? If this point is mirrored, it's going to be over here at minus 6 commas.
Yeah.
Okay. Because it's got to be exactly the same distance on the other side.
Right.
Okay. So for sure, we can eliminate those two answers.
Right.
All right. Now, choosing between these two, well, we got to, I guess, look at them. There's actually not enough information here to do this problem the way it's written, but let's see if we can decode what the instructor says here. So do you see how like the first are the same and the second are the same?
Yeah.
Okay. So it's saying here that it has 5 intercepts.
I don't get that. I've seen that before too on different questions.
Okay, so intercepts means crossings.
Okay.
It means it crosses the x-axis 5 times. So there's a lot of like what's called synthesis in this problem where they're relying on previous information. So there's 5 crossings. Okay.
Yeah.
So we know this is one of them, and this is another crossing. Okay, so if we assume there's one at minus 2, 0, let's see, that's minus 2, 0. Where must the other one be?
Then I have to be at 0 to be
2, 0.
2, 0.
Right. If you got one 2 left, there's also one 2 right. Is that okay? That's what the second point is saying. Okay. So that's 3 and that's 4. 1, 2, 3, 4, right? So we've got 4 of the 5. Okay. If this was true, let's just say 4, 0 were true.
Yeah.
Where would the other one be?
It would be at negative 4, 0.
Okay. And how many intercepts do we now have? 5 and
6.
And that's too many. But if it's at 0, 0, it's already like mirrored. It's like right on the mirror, like perfectly on it, kind of imagination. So really a good question, but kind of a tough set of answers for this.
Okay, that makes
sense.
That makes
great. Great. Okay, so let's go back to wow, your instructor really has chosen some challenging questions here to sort of guide you through this. Like the way I want you to learn it is kind of the way I started the lesson. It's like do this and see if you get through it. And these are all like summary questions for once you understand that. So, okay, if f of x is an even function, that's really, 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 really important. Okay.
Yeah.
I mentioned this in the previous problem. Which is the mirror?
Right down the middle.
Right down the middle. And this is the x-axis and this is the y-axis.
Right.
So since it's an even function, the mirror is the y-axis.
Oh, okay. I thought it was the one above, the y equals x, because it would be the same on both sides. In my brain, that's how it works.
So y equals x is right here.
Mhm.
And that's something different. You do
Yeah.
see that in this class, but that's it. So like, I don't know if you're into note cards or you know, you do a Quizlet, but like for me, a note card here is like even function on one side, and then on the other is symmetry, y-axis on the other.
Right. That makes sense.
Like to do well in this part of the class, you got to be able to get up every morning and be like, okay, even function, symmetric about the y-axis. That's how well you got to know this stuff.
Uh-huh.
Okay, so related to this question is if it's an odd function, and we haven't really talked about that except to show kind of what it means. It has what's called origin symmetry.
Mm-hmm.
Origin symmetry, and it's also referred to as a rotational symmetry.
Okay.
Okay, so if this is my quadrant 1,
Mm-hmm.
okay, it's going to look the same in quadrant 3, just rotated. So imagine somehow like you could rotate this line, it would look something like that.
Okay, yeah, I've seen that before.
Okay, now if that example isn't clear, let's try one more here. We will go, oh, sorry, jump. Let's do one more here. So let's say your line looks like this in quadrant 1. Your rotated line is going to be down here. Okay.
Right.
And this is rotated 180 degrees.
Okay.
So if you were to go all the way around, that's 360 degrees, but you stop halfway.
Got it.
Okay. All right. Boy, they're just okay. So let's look at question 5. This is just awkward. Okay. All right. The graph of f of x consists of 14 points. Okay. So what that means is in the xy plane here, we got 14 dots somewhere. It says 6 of the points lie in quadrant 1. So quadrant 1 is over here. Where is quadrant 2? Do you know?
Quadrant 2 is below it? No,
it's here. It's here. And I don't, but that's why somebody came up with this. We can't ask him, but this is just something again to know. You just have to know this to be able to do well in this course. So 6 of the points lie in quadrant 1, and they're telling you that it's an odd function.
Right.
Okay, so let's just say the first point is here. I showed you a graph previously. When they're in quadrant 1, where do they rotate to?
Rotate to quadrant 3.
Exactly. Okay, so if there's my first point, there's the rotated point. Let's say that's one's there. There's the rotated point. So I'm gonna make 6 points in this quadrant. There's going to be 6 points down here.
Right. Okay.
Okay. Now, you might think, well, okay, Matthew, 6 plus 6 is 12, and there's 14. The answer is 2, but it's not. It's not 2. So let's talk about why. How many points can lie in quadrant 2? Well, let's just put a point there in quadrant 2.
Yeah.
Don't we also have to rotate it?
Right. So one would have to be in quadrant 4.
That's right. So the greatest number of points that can lie in quadrant 2, and they're actually supposed to always be in Roman numerals, is 1 point.
Okay.
Because that other point has to be over here.
Okay. Yeah, that makes sense.
Okay. So let's see here. We've done 1, we've done 2. Okay, we can finally look at 3. So 3 is symbolic. These are really tough to do. Have you taken the SAT or ACT yet?
No.
No. Okay. So sometimes on the SAT, ACT, the strategy here is to like pick numbers for variables. Like let's say you get this M here, but you want to pick like kind of not. You don't ever want to pick 0 or 1. You want to, if you're going to try a number, you try like 2 or 3, never 0 or 1, because all the research shows is that the people who make the questions, and I've made some of them, is that you pick numbers that students will try to keep them from getting the right answer. So, but usually when you get a symbolic question like this, you generally want to try some numbers. So what I mean by that is like, let's do this problem for f of x equals x squared plus 9 to the power of 2. And then let's do the problem maybe for f of x equals x cubed plus 9 to the power of 2.
Okay.
And if is it clear that all I did is just make that m the value of 2 and the value of 3?
Yeah.
Okay, so do this. Let's have you figure out what is f of minus x.
Okay. So that I'd make the x squared a negative x squared, and I would leave the 9, so it'd be plus 9 squared.
This becomes x squared plus 9 squared, right?
Right.
Is that what you got? Now it's the whole thing here. I mean, this is a little bit different than the ones we were doing. Is this whole thing the same as the original?
Yes.
It's even. Because you answered yes, it's even.
Right.
Okay. So we can't quite answer this yet, but if you had to make a guess, you would say, well, it's even. So maybe it's, maybe it's A, maybe it's B, not really sure. But let's go with the other one here. Let's see if there's anything that we can kind of uncover from this part. Okay, so it's parentheses negative x cubed plus 9 squared. And then this becomes negative x cubed plus 9 squared.
Right. Right. And then we do the
What was the next step after this?
we factored the negative.
That's right. So the second step, and this one, I don't expect you to know how to do this, but I'm gonna try to show you how to do this. So just follow along here. We're gonna factor out a negative from the inside. So that becomes x cubed minus 9. Do you see that?
Yes.
Okay, now it's still squared.
Right.
So when you square a negative, that goes away. So we're squaring this negative, and then we're squaring the x cubed minus 9 squared. So this negative squared becomes positive x cubed minus 9 squared. So whether you follow that or not, that's not important. I'm sorry, what? Oh yeah, is this the same as this first line up here? Is it exactly the same?
No.
No. So it's not even. Well,
Right.
first of all, this line right here wasn't the same, so it's not even. This last line, it means it's not odd, so it's neither.
Right.
Okay. So this is like me giving you an example of a problem like this. So there's really, based on this, it's definitely not odd. Okay.
Right.
But is it always even? Well, it wasn't even for this one. It didn't work out for it being even.
No.
On the right, but it was on this one on the left. So what was the difference? Well, the difference was trying 2 versus 3. Well, what's the difference between 2 and 3? 2 is even and 3 is odd.
All even values of m.
Right.
Okay.
So this is a really difficult question. I would not expect you, I don't think you'll see something like that on your test, but hopefully the steps of like plugging in f of negative x, comparing it to the original, hopefully that's clear.
Yeah, they didn't do any like practice problems on it. They just like put it on the homework, and I was very confused by the m.
Sure. Sure. Okay, number 4. Actually, we're gonna do number 6 next.
Okay.
We kind of already did this, so we can go through it pretty quickly. But let's it should make more sense here. Determine whether this function is an odd function. So to do that, you have to first determine f of minus x. And we already did that earlier.
Right.
Okay, and we found that that's 9 minus 4x squared. Okay, and then you factor out the negative. So when you factor out the negative, what does 9 become in here?
9 becomes a negative.
It's plus 4x squared.
And plus.
Right. And so you're trying to figure out, it looks like it's this last one here. Determine whether 9 minus this is, let me see here. Boy, this is a little awkward. So this first one is okay. So there's a notational problem here in the second one. Without getting into why they're wrong, let's talk about why these are right. Do you see how the way I wrote this with negative x, only the negative x being squared is shown here and here? Okay.
Yeah.
All right. So this first one is for whether it's even, and the second one is for whether it's odd. And the reason is because this is the original. That's the original. And this right here is the original, but inside parentheses with the negative.
Right.
Okay. So this is the correct answer if I haven't sort of said it.
Yeah, no, that makes sense. Because it's an odd function.
Yeah. Is your dad there to just have a short dialogue with nothing about you, it's more about this if he's available?
I'm right here.
Hey Josh, if you can't tell from my language, like these are some very these are tough questions for students learning this for the first time. And you know, I have no issue here helping your daughter with these, but like I want you to know as like a parent, like if this is like level 3, you know, where I would think she'd be at level 1, and for some reason this is the assignment, and we can't change that. But you know, I want you to know that, you know, we're doing way harder questions than where I would think she would be at, you know, learning this for the first time or even the second time.
Yeah, it's a math program. They have her watch a video, then all of a sudden they give her these questions, and it's like, hello, you know what? I get what you're saying. I mean, it's over my head. So
sure. Now, yeah, I'm not expecting you to do anything about this. I just want you to know, like, the way that, like, you know, your daughter would learn this best is okay. Here's an example problem, and then, you know, you do one like it, and like, I'm just not seeing that in this assignment here. These are very conceptual problems. They're like they're the kind of questions like I actually like, because they test your knowledge of this subject at the end, but not at the beginning. They're very challenging. So
right,
you know,
she was just introduced to this yesterday. So
yes, yeah, these are they're just very tough. Okay, unless you got anything else you want to say, I guess I'll just go through work on this last question with her. But thanks for hearing me out.
We're gonna do that's why we scheduled 2 times a week. We're gonna do 2 times a week.
Great, thank you.
So you're scheduled with her for next Thursday for Thursday.
Yes.
So I just want to make sure that it's not at 8 o'clock at night. I don't know.
Yeah. Let me actually look at that right now and give you an answer. I've got her down for 7 on Thursday.
Okay. I don't know why it's 6 to 8 tonight. That's kind of weird.
Yeah. Okay. So yeah. So let's Emma, if you're still there, let's take a look at this. Okay. Suppose f of x is a function such that if p is less than q. So again, let's pick some numbers here. Let's let 2.
Okay.
And let's set q equal 3.
Got it.
So 2 is less than 3. You agree with that?
Yeah.
And then f of 2 is less than f of 3. So here's what that means. Let's say, actually, let me graph this a little bit better. So here's 2, and f of 2 just means the y value. So let's just say we'll just pick 4, and then f of 3 is maybe up here at 6.
Okay.
Okay, so this is 2, this is 3, and this is f of 2, which we know to be 4, and this
Right.
is f of 3, which we're just calling 6. We're just picking some numbers because that's the only way as a student learning this for the first time, like you even have a chance. And we don't know what's happening in between here, but let's see if we can answer this question. Okay. Okay, so one possibility is that these points are mirrored over in the other quadrant.
Right.
And I'll do that in red. Like we don't know, but like I guess it's possible that this is here and this is here. And if that were true, that would make it even.
Right.
Okay. But if it were odd, then the points that they rotate this time. So they actually end up being, let me get these in the right spot here. There's one there, and then there's one there, and that's odd.
Okay.
So how to answer this? It's rare that I'm stumped because I want to say the answer is that we don't have enough information, but it's possible. Let me just look here and see if there's something that I'm missing. On this. So like maybe the numbers we chose were not like we're choosing very specific numbers, and so what it could be, let me copy this into another, let me just copy this down here and see if I can show another example here. So let's just say this time that P is -2 and Q is 3.
Okay.
Okay, so now this is f of -2 and this is f of 3. So the reason I did this is that -2, let's say -2 is over here. Let's just put a dot there, and then 3, I don't know, maybe it's up there. Okay.
Okay.
And this still holds true. This is below that. So could it be even? Well, if it were even, here's what would have to be true. There would have to be a point here and a
Right.
point here. And that is possible. Like we could fit a curve. We could fit a curve that, you know, go through those points. That's reasonable.
Right.
So it could be even. Okay. Now, but could it be odd? Well, for it to be odd, this point here would have to be rotated over here. And then this point up here would also have to down here. Let me get this from the right spot. There, right, somewhere like there. So the curve, well, so here's another example. This could work. It could go like this. See how that works still?
Yeah.
So I guess the answer is it could be either. It could be both.
Okay.
Although I don't feel very good about this because I just don't feel like, you know, if this was an oral exam and your instructor was here and you could present all this information to them, you probably would get the right answer. This one, you know, it's one or the other here. Let me just, sometimes, and if you're not already doing this, I mean, sometimes, let me see here, maybe check your notes. Sometimes, you know, these online things have like little notes sections. Maybe this is in there.
Okay.
You know, I would just double check that before you submitted it. All right, we got a couple Couple minutes left. Emma, is there something else from the lesson today you would like me to cover again with you or go through?
I guess just probably, if anything, like just more problems, just repeating it. My dad, when I was doing more like grade school stuff and he was helping me, we repeated the same thing over like 15 problems.
Yeah, I mean, repetition is the first principle of learning, the good repetition. So
Yeah.
okay, let's do this. Let's say I give you this function f of x equals 2 minus x. Okay, I want you to find f of minus x.
Okay.
So go ahead and take a moment, see if you can determine that.
So that would be 2 minus, in parentheses, negative x. Yeah.
What does that reduce to?
That would be 2 plus x.
Perfect. All right. Now again, let me give you a new f of x here. 2 minus x minus 3x squared. And this time, again, I want you to find f of minus x.
Okay. Negative x minus 3 parentheses negative x squared.
Okay, so I'm gonna write my final answer. 2 plus x plus 3x, I'm sorry, minus 3x squared. Get this right here, minus 3x squared. Does this match your answer?
Yeah.
Perfect. Okay. So last thing, let's look at this problem that we just wrote, and I want you to factor out a negative.
Okay.
And I want you to figure out what's going to go inside parentheses here. All right, so does your answer match what I have in parentheses here?
Yes, it does.
Perfect. Okay, well, that does take us to the end of our lesson for tonight. If your dad's there, let me know if you have any questions or anything you'd like to discuss.
I mean, it's just really hard with how my school's program, they give like problems, like the teacher will put up problems and like work it through, but it feels like he doesn't even say what he's doing when he's working it through. He just does it and feels like it should be obvious what he did.
Yeah,
I'm sure maybe someone else could understand like right away, oh, he minus that. It's just really hard for me to grasp all that. They don't just make it plainly obvious.
if you have time, Emma, I would recommend reviewing the notes that I send you, even watching the video playback. It's always helpful to just see the stuff one more time. Really will help.
Yeah. Okay. Thank you. My dad's
All right,
here.
well, I will see. Oh, great. Josh, you have anything you'd like to follow up on from the lesson today?
No, I don't do any questions.
No.
Great. So I'll see you guys on Thursday then.
Yes.
Yeah.
Thank you.
Thank you.
All right. Have a great night. Bye now.
Bye.
Bye.